How are you guys doing? Hola. Last week, here we go. Yes, it is. It's the last week of classes, my friends. Getting very close to the end. How's your last week going? You guys doing all right? Hello, Falcon. Good to see you as always. Going all right, Ike? Danny, I can't extend those. Yep, still weird. The background music sounds much louder than my voice. What's the actual date for Project 2? Friday, May 15th. Friday, May 15th. What percent of the grade is Project 2? Let us... It's not a group project. It is not a group project. 15% for undergrad students. I'm pulling up the syllabus. You're probably right, Kevin. It's okay, Kevin. So yeah, if you look at this revised syllabus, Project 2 will be worth 15% of your grade if you're an undergrad. It's worth 12.5% if you're a grad. Yes, the two projects are equal, Goldfish. And then if you saw my announcement, I'm gonna drop your lowest homework and then calculate the average from the remaining ones. Is Project 2 going to be equally as fun? Oh, I hope so. Let's look at it. I think it's fun. So, there's two parts, right? The first part is designing a regulator for a self-balancing robot. And it's actually all of these parameters in this table. I tried my best to get an accurate measurement for it, but it's for this one. So everything you see in that table, it's based on, it looks like the guts are just like falling out. All of those are based on this guy. So like the weight of everything, the mass, the inertia, I tried my best to make it accurate. So keep that in mind. You're making a controller for this. Yep, Max, it's going to be the same weight as Project 1. Same weight. So yeah, here's the table. There's two stepper motors. Each one has a mass of 300 grams. I tried to get the inertia, the tire mass, tire radius. And then here's some more parameters. And then you don't have to derive the equation of motion. I already have like a linear continuous equation for you where you got this alpha, eta, gamma. Those are all defined here. And if you want to get the actual numbers, you just look at the tables up above. And what I would do, you'll notice all these are like in grams and centimeters. Like all of those units are consistent. So you don't need to bother with any unit conversions. You can just take these numbers, plug them in, and then so your final results will just be grams, centimeters, whatever. So this is a little interesting because usually in this class we've only measured one output. For this one we're going to measure two outputs. So and this is going back to the real problem. This is what we actually measure on that robot. Number one, you measure the pitch rate, so how quickly it's tipping over, and you use a gyroscope to measure that. And then the angular velocity of the wheels. Because it's a stepper motor that I'm using, you pretty much know the velocity of the wheels because you know how many pulses you're sending per second, and that just directly provides the velocity of the wheels. So I'm not using a sensor per se to measure the angular velocity of the wheels, but we have a pretty good idea of what they are. So this is our output vector. It's got the angular velocity, well, two angular velocities. The control input is the angular acceleration of the wheels. So you program the steppers to generate a certain acceleration. And when you do that, it creates a reactionary torque on the chassis, and that's what keeps it upright. So don't be scared by like all the info on this front page. Like what you need to take away from it is here's a continuous time model. Here's your outputs and input, and if you want to get numbers, you just use these definitions, use the tables. I'm just giving you all this info so you have a complete picture. It's kind of fun. It's a real problem. Okay, so let's get into the meat of part one. Like, what do you actually have to do? There's a lot of text on here. That's just because I'm trying to give you a lot of hints. Okay, I'm trying to give you as much detail as I can. So the very first part is get the continuous time state space model, assuming that these are your states. So your first state is the pitch angle of the chassis, so like how much it's tipped over. And the second state is the pitch rate, like how quickly it's tipping over. So based on these state definitions, I want you to give me, you know, the state space model. So you got to give me the AC and BC matrices. And I make a note here, at this point, you don't have to worry about all the numerical values. You could write the state space model in terms of alpha, eta, and gamma. It's just like a pen and paper problem. So that part, really not too bad. The second part is taking that second order state space model and then assuming that we get 100 samples per second, convert this into discrete time state space. And you can just do that in MATLAB, okay? So part two, no problem. This is where it starts to get a little more interesting. Coming out of part two, you're gonna have two states. We're gonna add a third state to our model. And it's kind of like an integrator. If you look at this equation, it looks really similar to an integrator equation. I mean, I guess it is an integrator equation, but we're gonna add the wheel velocity as a third state. The reason that we're doing this is, excuse me, we want to balance the robot, but make it stay stationary as well. So physically, there is a way to balance this robot if you, hold on, let me show you. Like if you're spinning the wheels at constant velocity and it's like rolling across the table, you could keep this thing balanced, but the wheels would be spinning. So it's like upright, but it's just translating, and it just, it'll roll away from you. But we want to keep this upright, but keep it like in the same spot so that when you push it, it'll like, it'll roll forward a little bit, but then slow itself down. So if you don't explicitly tell your controller to do that, it'll get your robot upright, but then it'll just keep rolling away. A runaway droid or something. So that's why we make it a third state, and because this is a regulator problem, the goal of the controller is to drive all of these states to zero. We need to make that rogue AI. Amen. So your controller is going to drive the pitch angle to zero, the pitch rate to zero, and it's going to try to make the wheel angular velocity also go to zero. So when you do your simulation, you'll see this. So when you add this new state, you just have to change your A and B matrices so that the Velociraptor droid, amen. So now you'll have a third order state space model. Okay. Next, you're going to define the control input, and it's just going to be using you know, the standard form for a regulator. So our control is the angular acceleration of the wheels, which is u, and it should be minus k times our states. Well, really, in practice, this will be the estimate of our states. Okay, so you're going to choose the state feedback matrix so that our settling time is approximately 1.5 seconds with 30% overshoot. So you can imagine what the robot's going to do if it settles in 1.5 seconds. Like, I don't know, like you try to tip it and then it like does something like this. Like it'll kind of be slowly correcting itself. So it'll be like gentle. If you made it like 1/10 of a second, it would be like really jerky. So I chose 1.5, so it's just kind of like chilling. It's just correcting itself kind of smooth. I don't know, maybe it's too slow. Okay, so the controller is going to rely on our estimated states, right? So we have to make an estimator. So the estimator is going to estimate all 3 of our states. The pitch, angle, which we're not directly measuring, by the way, which is cool. Like our estimator is going to tell us how many angles, what am I saying? The degree to which the robot's tipped over, but we don't have a sensor that's actually gathering that. So yeah, this is just reiterating. We measure the pitch rate with a gyroscope. We measure the wheel velocity. Okay, so you're gonna have to define this C matrix, which isn't too bad. You just have to figure out, like, what do I have to multiply my states by to return these 2 outputs? We're gonna have, I'm giving you some target performance for your estimator, so I want it to settle in 1/2 second. So that's 3 times faster than the controller. And we have an overshoot of 20%. Now, this is a little different because, once again, we're using 2 outputs. So far in the class, we've just used 1 output. So the dimension of your L matrix, it's not just going to be a column anymore. It's going to be actually 2 columns. And you can use the Acker formula if you have 1 output. But once you start having 2 outputs, Acker won't work anymore, in MATLAB at least. So you have to use the place command. And here I give you the syntax for using place. So, I mean, it's fine if you just use this code to give you back your L matrix, but you're gonna have to, of course, determine beta star, like your estimator poles, on your own. So that's not too bad. Here's the last part, okay? Once you have your controller and your estimator, we want to simulate how it responds. So I want you to simulate this system. Here I give you some initial conditions for the true states. So the pitch angle is 0, the wheel velocity is 0, but it has an initial pitch angular velocity. So think of this as like, this is simulating your robot starting at rest and then somebody like pushes it over and then your controller is going to try to react to that. So it's like an initial angular velocity that somebody gave. And then, but we'll assume that our initial estimated states are just 0. So there's some disagreement between our true and estimated states at the beginning. Okay, so you got to simulate this, and you got to make me a couple plots. So I want to see both of our system outputs as a function of time, the control input as a function of time, and the state estimation error as a function of time. So it looks like a lot, but it's not really. It's kind of like comparable to our last homework, part 1. What questions do you have about part 1, or does that seem pretty decent so far to you? It's like the last homework, just fancy. The stream is sponsored by Nalgene. All right, let's move on to part 2. No, I hear you. I hear you, Falcon. It's gonna take some time. Like you've just barely seen this, so it's like hard to know. Chris says K will be 3x1. Close. Close, Chris. Okay, Chen, if we regard theta as the integral factor, why do we still use theta? Okay, that's a good question, Chen. Like, because if it's like an integral state, before I was saying you don't need to estimate the integral because, well, for one, sometimes you have controllability issues. I did this in advance and I didn't run into controllability issues, so I was like, what the heck, why don't we estimate that as well? So I don't have a very good reason other than I was like, well, it works, why don't we do it? Mild Goldfish says, can you post homework 7 and project 1 solutions? Yes. I've been working on some of that stuff in the background, trying to make it nice and clear, and I hope to get that stuff out no later than the end of this week. So okay, let's talk about part 2. I think part 2 is shorter than part 1. So this goes back to project 1, where we're designing a controller for this DC motor, and here is, it's the same transfer function. The output is the angular velocity, the input is the voltage, and same sampling frequency as well. So we're trying to control this, but I want to use state space techniques. So first, put this in state space form. This is already a discrete time system. So just like our last homework, you don't have to do a continuous to discrete conversion when you do this. It's just converting it. Because we're doing a tracking problem, you have to define reference states. Because your controller compares your estimated states to your reference states, and that's how it calculates your control input. So let's assume that we're gonna just do a step reference of 2 pi radians per second. So figure out what the reference state would be for that. Then we're gonna add an integrator. So the way you do that, you're gonna augment the state vector to include the integral of the output error. And then I want you to update your A and B matrices and just call these like A augmented and B augmented. Now, once you have this augmented system, get your feedback gain matrix so that we have a settling time of 0.6 seconds and a 20% overshoot. And then next, We're going to do an estimator. And for this one, I don't want you to estimate the integral state. Just estimate your first state, your original state. We want the settling time to be 0.2 seconds. That's 3 times faster than your controller. It's going to be kind of funny doing this because like the state space system, it's low order. Like L is going to be oh, Ike, you have some questions. We'll be getting our Project 1 grades soon. Yeah, unfortunately you're going to get those next week. Things got bottlenecked a little bit. And will you want the project submitted as 2 separate codes? I would probably do that. I would design 1 code for part 1, 1 code for part 2, tack those on as an appendix to your PDF when you just submit project 2. So submit like 1 document, say part 1, part 2. I would throw all your code at the end in an appendix. Okay, last part of part 2 is you have your controller, you have your estimator. Let's simulate the system when you have a reference signal of 2 pi radians per second. And then I want you to give me these plots. So, I don't know. I think it'll be good. Both of these are designing controllers for real systems, which is always a good thing. It's not just an abstract thing. You're designing digital controllers for real hardware. And like I said in my announcement, I'm going to be here the rest of this week. I'm going to be here next week. So just start chipping away at this early and then just drop in whenever you can, whenever you're available, and give me your questions. I want to devote, the rest of my time here this week and next week to help you guys just push through. So Baba Rao says, no more classes, no more official classes Friday. No, we'll have, we're gonna keep meeting, right? So this Friday, I'm not gonna introduce any more new content. I don't think I will. What I might do on Friday is, I think it's good to, once you get through a class like this, to summarize, like, okay, where did we come from? How do all the topics connect? What are the advantages and disadvantages? So what I might do is make like a flow chart and put that together to try to, like, in my mind, summarize all the stuff we've done. Try to put a bow on it. So we've come a long way, my friends. We started first day with like the propagation of rabbits, and now we're doing self-balancing robots. Good gravy. You guys have done a fantastic job. You really have. You make me proud. Plus, we've had a lot of fun. We've had fun. So yeah, guys, if you have, I know I just laid a lot on you today, but I'll hang out till about 1. You can give me any questions you have, any concerns. I know some of you sent some emails. I'm catching up on that, so If I haven't responded to something you sent me, I know there's maybe just a couple of you who I'm behind on. I'll get back to you soon. Any concerns with grades, whatever, let me know. We're gonna take care of that stuff. Ike says, truly superb class. I appreciate that, Ike. Yep, I'll still be around for office hours this week and next week. The grad project deadline is still the same, Babu Rao. So the graduate project is due... Monday, May 18th. And I can't extend that because yeah, because grades are due I think the 24th. And I have to read all this stuff, give you feedback. How do we submit the graduate project? Did I not put a submission link? I'm gonna have you submit it. Oh, I need to make a submission link. You have a project due the 26th? I don't know how that's gonna work. Look at this. UB grade deadlines. This is from the Office of the Registrar. Yeah, spring 2020. It's due the 23rd. So, that's what I'm gonna do. We need to make a report for a review paper. Yes. Can the deadline for project 2 be pushed a bit? No, Gerald. And once you get going on it, it's really not as much as it looks. Plus, that's why I'm having office hours just like all through next week. Any help you need, I'm here to give it. Once you get going, I think you'll be surprised. It should go along pretty quickly. And they're fun problems. Yes. 1 week and then rest. What are the odds school happens again on time at the end of August? Now, last I heard, they're weighing a couple different ideas. Like, there's a hybrid model. Look, this is all like hypothetical, and this isn't like official UB, but like a hybrid model would be some people are on campus, some people are off campus. And I'm not sure how you, like, maybe it's voluntary. Like, if you want to not come, then maybe there's accommodations. I don't know. Or maybe that's there's hybrid and then there's flexible models. I think the flexible model is like we expand our opportunities so that it's flexible for students. Like, you can be offline or online. I mean, you can be in person or do online stuff. And then you got exams on the 14th and 15th, Gerald. That's the reason I asked. Yeah, I know. I'm sorry. I know. So they're talking about that, like maybe having class where we have to space people out. Like we enforce like you can't sit next to each other. My gut is telling me it's gonna be like the same. I mean, it'll go back to normal mostly. That's my gut. But maybe there's gonna be little adjustments about suggestions of like where everybody sits, where you can eat. Like maybe in the student union they'll tape off some chairs or something. I don't know. But I hope this all resolves quickly and safely. Because it's better when you can have human interaction. That's just the way it is. Did you guys do anything special for May the 4th, Cinco de Mayo? Walking through NSC is not social distancing. Yeah. Oh my goodness, NSC is the place where that's where it bunches up. Ooh, you slept good and watch Rise of Skywalker on Disney Plus. Good. Watch the new trilogy and counted every time Finn shouted, "Rey!" I just imagine every time he shouts, he's saying Rey. Probably 50% of the time he is. I want to watch The Mandalorian again. Boggs Booney dressed up as Slave Leia and lounged around. I hope you did. Dr. SS, are we done for today? Yeah, we are, Babu Ram. I'm just going to hang around. If anybody has questions. Good, you get going on your other projects. I wish you the best of luck. See ya. What's the best order to watch Star Wars in? I mean, you could watch it chronologically, but I would probably watch them in the order they were made. Like episode 4, 5, and 6, then 1, 2, and 3. Okay, yeah, Joe's got it. 4, 5, 6, 1, 2, 3, 7, 8, 9. That's a good way to watch it. I think chronological, it's okay, but that's not the way they came out. Like you'll miss some of the surprises and whatever they intended for when they made these. Because when you watch 1, 2, and 3, it's supposed to be like, oh my goodness, this is the backstory. There's all this like revealed stuff about people's pasts. But if you just start by watching 1, 2, and 3, you'll just be like, oh, whatever. I want to watch The Mandalorian again. Rank Star Wars movies to the best of your ability, and don't forget to leave 8 on the bottom. Okay, if I had to rank my favorites, okay, like probably Lewis, you can certainly join Summer Dynamics, I don't mind. Maybe episode 5 is my favorite. Followed by episode 4, maybe. I really don't like. Okay, nobody likes the original trilogy the best, right? Like 1, 2, and 3, but The Phantom Menace, I kind of like it, honestly. Like, I'm excited to watch that one. It's got pod racing. It's got Darth Maul, who's just cool. It's got Liam Neeson. It's got Jar Jar Binks. I mean, who doesn't love Jar Jar? Okay, so probably I like episode 5 in first place. Then I like 4. And then third place for me is probably The Force Awakens, episode 7. I enjoyed episode 7 a lot. Maybe episode 9 after. I liked Rise of Skywalker. I got it spoiled for me. It was my own fault, so that one got spoiled a little bit. Does anyone know the name of the soundtrack that was playing in the beginning of the lecture? It was kind of upbeat. I know it's been in other sessions. Oh, I can show you. Is it this? I want to watch the animated Clone Wars because apparently there's some important plot development for the Mandalorian in there. I know you can't get into it, Boggs, but it's like Paw Patrol. Do any of you guys like Clone Wars animated show? Does it have redeeming qualities, or is it Paw Patrol? It gets much better animation-wise as it goes on. Okay. After the first season. Okay. Okay. It's a 10. Wow, how many seasons are there? Seven. Wow. Okay. What, like 10 episodes or something? How long is each episode? All right, because there's Clone Wars and then there's another show, Rebels. 25 minutes, 22 episodes per season. That's a lot of content. Okay. Yeah, that's a commitment. Okay. Yo, when are they gonna drop a trailer for Kenobi? I got tricked a couple times. I watched like a fan-made trailer. Mandalorian season 2. Cannot wait. Like, okay, Clone Wars introduces that. Wait, I don't know if I don't want to spoil things. I'm gonna hold that back. Unpopular opinion, Matt, you hated The Mandalorian? Why'd you hate it, man? Nothing happens. What do you mean? They fought? I mean, it's so Mandalorian is more episodic, you know? It's like each episode is a contained little adventure. Wait, you timed them out? Really? All right, bring him back. Bring him back. The thing he said. Oh wow. No, I think it's. I don't know. I really enjoyed it. Yeah, there's a tiny Yoda. What else do you need, Max? You're just let down. You've been hurt. Didn't live up to your expectations. That's an unpopular opinion, Max. You better be careful. You stand by your decisions. Good for you. Be decisive. Be confident. Max has spoken. This is the way. Now it's a good sleep show. Yeah, it's like a comfortable show. If that's what you mean by that, Chris. It's like something you can go back to. It's like a comfort food, I think. That's a show I could just watch again and again. Changing topics. Have you guys seen Ozark? And is it good? I've heard some good things. I might want to check it out. You just started that, Max? Best show on Netflix? Okay, so people like Ozark. What is it, like Breaking Bad, or I don't know too much of the plot. Don't spoil, but I heard there might be some drugs involved, some smuggling. It's exactly the same as Breaking Bad. Oh boy. I loved that show. It's hard to watch. It's heavy content. It's heavy, but so good. Agents of S.H.I.E.L.D. Huh. End of season 3 is an all-time TV moment. Okay. Okay. Might have to do it. Might have to watch it. Is Kevin still here? Is this the track you were looking for? Because this thing grooves. Okay, going back to the Mandalorian Game of Thrones convo, I'm stoked that Pedro Pascal was cast as the Mandalorian just because he was so sick as Oberyn in Game of Thrones. Believe it or not, I haven't seen Game of Thrones. Believe it or not. But I've gone back and YouTubed stuff like all the mountain fight scenes. Seems like it has some really cool characters. I saw that, Joe. The mountain just broke a world record for deadlifting 1,200 pounds. It's unreal. Maybe I can find this. Mountain deadlift. Yeah. 3 days ago. Oh my goodness. Oh, it's this song? Alright, let's make sure you know what it is. Okay, it's Euphoria, 1,000 Eyes. I'll type it in the chat. Something like that. Whoa, what's going on here? Is this a Game of Thrones fight? Oh my goodness. Valhalla! Is that what he's yelling? Wrist straps, how's that fair? If you can't grip it, you can't lift it. What are those weights made of? They must be like tungsten. Or maybe they're regular plates and he's just so freaking huge. Oh my gosh. It looks like a pool noodle. How much it bends? Watch, he's gonna crush this guy's skull. Look at how it just bends. Bloop. Oh, it's a Texas bar made to be whippy? Wait, why would they intentionally make it flexible? Oh, it wouldn't be legal in any federation. They use it specifically for records. Funny you say he's gonna crush someone's skull. No, I know. I know what he does in Game of Thrones. So you're higher off the ground when the weight leaves the ground. Oh, I see. So you get some more like mechanical advantage. That makes sense. Are you, Nathan, are you allowed to use straps in Federation like this? Watch your toes, man. Holy cannoli. Nathan, wait, so is this record a sham? Is that what you're saying? The guy is so huge. I see. I see. Straps or not, I can't lift 1,100 pounds, given the record. Yeah, good point. He, marathon world record where the dude used a ton of pacers. Wait, what's the story with that? Like, there was Oh. So this is more showing it's possible rather than can be done competitively. I guess. I mean, Hafthor, he wins the world's strongest man competitions. He's definitely a monster. I wonder if he would win in competition as well. Oh, he hasn't been ranked number 1. Okay. Beat the world record by 1 minute and 18 seconds. Two-hour marathon barrier. 1:59:40. All right, Kevin. Good luck to you, my friend. Take it a day at a time. What does that mean your mile pace is? It's like 23 miles, right? So 120 minutes divided by 23 miles, right? Oh, 26.2? minutes divided by 26.2 miles. Are you saying that he was averaging 4-minute 30-second miles? Am I doing this right? Is this right? Let me tell you something. I don't consider myself a runner, okay? But like I've been running a bit over the past couple years, and I can what is it? I can run like, okay, that's okay. I know nobody considers me a runner. I'm just trying to like compare this because I ran like 4 miles the other day. I don't know, like 9-minute 30 pace or something. Like it took me 40 minutes. And I was hurting. And this guy goes twice as fast for 6 times the distance. A 4.5-minute mile. I mean, yeah. What? What's like what's your 100-meter pace? So you do okay, 1 mile to meters, 1,600 meters. So you do 1,600 meters in 4.5 minutes. If we divide that by 16, that'll be so you're doing 100 meters in confusing myself. 0.28 minutes, it looks like, yeah. So 0.28 times 60. 16.8 seconds for 100 meters. The world record 100 meter is 9 seconds or something. I guess all I'm saying is like that's a fast 100 meters. 16 seconds. Like if I'm dead sprinting 100 meters, how fast would I go? Maybe 12 seconds? I haven't timed it. But if 9.76 is the world record, and I'm going to be really close to the world record, I'm probably going to get 12 seconds. Because I'm that fast. Well, this guy's holding 16-second times. Boggs Booney, that's my brother Nathan. He knows everything about Olympic sports. Well, he competed in the throws events in college, so he knows all the track people. Okay, one more crazy feat of human origin. Have you guys heard of what's his name? Max, you probably know this guy. The Iron Cowboy. He did 50 triathlons in 50 days in 50 different states. Wait. No, he did 50 Ironmans, I think. An Ironman is... Wait, is it just... 50 Ironmans in 50 days in 50 states. Look at this. If you guys aren't familiar with the Ironman, it's a marathon, so 26.2 mile run, 112 mile bike ride, and a 2.4 mile swim. He was doing this every single day for 50 days in 50 states. Yeah, it's like yeah, I heard about this on a podcast, and then apparently like his toes were in bad condition. Like his toenails were falling off. Wait, what am I? I know, it couldn't have been, it can't be good for you. Yeah, I mean, there's... You could do that if you didn't enjoy beer so much. There's very few people in the world who can finish one Ironman. I want to say it's like on the order of 1,000 people or something. He ate 3,500 calories every morning. 7,000 to 8,000 calories every day. 3,500 calories before every bike ride. My feet were just destroyed, blisters between my toes, toenails coming off. Your uncle biked from his home in Alaska to Buffalo? Wow. That's quite a trip. The biggest struggle... He would fall asleep on his bike. He fell asleep, fell off his bike, and crashed at mile 30. Me planning on doing a marathon like this, I am not nearly in the right kind of shape for that. Oh my goodness. Some disorder that has the body produce lactic acid at like a third. Yeah, I mean... So yeah, I was listening to this podcast about the Ironman, and your body physically shuts itself down once you reach a certain level of exertion. Like it has nothing to do with how much you want to push through. Like that's why some people, when they run marathons, they just collapse at the finish line. And you're like, well, why don't they just go 2 more feet and cross? It's like, you don't have a choice. Your body's like, you're done. So these people somehow, when they train, they're able to suppress the body's natural inclination to shut itself down. I don't know if it's some disorder. Maybe some people don't have that suppression. You're doing a 15K at the end of the month, but I'm spending all my time studying and not training, so I'll probably finish in 3 hours. Oh man. He averaged 4.5 hours a night of sleeping. Oh man. Unreal. All right, ladies and gentlemen, I'm gonna go eat some lunch. I'm gonna be back here at 3 for office hours. You're always welcome to join. Other than that, I just hope you have a fantastic day. I hope you're feeling good. Hope school isn't getting you down. Just keep chugging along. You're very close to the finish. I will see you guys around. Check your email. I made you a gift. Uh-oh, what did you do? Ooh. Dude, I'll check this out. Thanks a lot.